Hello and welcome. In this video, we look into the backbone of most of today's chatbots using conversation chain from Langchain. One important component of this chain is memory. A memory system needs to support two basic actions, reading and writing. A chain will interact with its memory system twice in a given run. After receiving the initial user inputs, but before executing the core logic, a chain will read from its memory system and augment the user inputs. After executing the core logic before returning the answer, a chain will write the inputs and outputs of the current run to memory so that they can be referred to in future runs. The two core design decisions in any memory systems are how state is stored and how state is queried. First, let's take a look at what memory looks like in Langchain. So initially, I'm going to create a virtual environment for my Python application. In order to activate my virtual memory, if I'm using Linux or Mac, I will use this instruction. So I go through and call the binary folder and activate my virtual environment. Now, if you are in Windows, the way that you would interact is you would call the venv and then you go to scripts and then you activate. So now that I'm in the virtual environment, I want to install the latest version of Langchain. So the first library that I'm going to look at is the ConversationBufferMemory. This is a very simple usage of memory, and then I can instantiate my buffer. There are certain things that I can pass through it. For example, I can set up the memory key to be, let's say, chat history, but for now I would just put it as a default so that you can see the results, and then I'll change things. Now, before I go any further, let's take a look at what this library has. And so in order to do that, so basically I'm in the Visual Studio Code, which is my IDE, and I want to go through and see the underlying methods and packages that I'm calling. So for instance here, if I hold my command or the control in Windows or command in Mac and click on this, it would actually go, as you can see, it goes into the library where this class is being called or is being instantiated. So right now I'm in the buffer.py under the memory under Langchain. There are some methods or it has some attributes. For example, human prefix, AI prefix, and memory key. Okay, so now that I have instantiated my memory, then I can start having a conversation with that. So I would add a memory.chatMemory.add user message or AI message. If I add the AI message to this property or to this memory that is inherited from ConversationBufferMemory, I can also add chat memory. So I add user message, and I would also add this too here. Now let's take a look into the chat memory where I can have access to chat memory. By default is given this field value, and it's of type BaseChatMessageHistory. So BaseChatMessageHistory, when I click on that, it would give me this full-fledged class, which is under the chat history. So if I want to import chat history or BaseChatMessageHistory, I would actually need to call it from here, from chat history to py, which is under the Langchain core. So this says, if I look into the doc string, it has some descriptions of what the base chat message history is, and how I can, showing a default implementation of that, and some of the decorators that are used here, what is actually passing here. So you can see that this is passing messages as a list of type base message. And one important thing to understand is these are the methods that you can use. So you have some asynchronous methods, and then you have some regular or synchronous methods. So async methods, which is outside the scope of this video, but in short, when you want to basically call to asynchronously pass some messages or to get some messages from the list or from your memory, then you can use this function or this method. So A is short for asynchronous, and get messages is pretty straightforward. So the two methods that you use here is the add user message and add AI message. Let's maybe add one more chat history here, the AI message, or maybe one more. Now, let's say I want to look into what I have under memory. So I would just do the chat memory again, and then do print memory. So before I do that, then I need to run this. So because this is the first time that I'm running a Jupyter notebook within my newly created virtual environment, so it asked me to install this PyKernel package, which is related to the Jupyter notebook being used in Visual Studio. So I installed that. This code runs well, and then if I run this, it says, the error says that this does not have the print memory, and this is because I was just following the GitHub Copilot. So I had the memory set up, and now I can call one of the methods from memory to basically just show all the variables that are stored. So I need to run this one more time. Okay, so that's run, and then if I run this, okay, this is the default name that is given to any history for memory, dictionary. So this is the default memory key. This is the stringified kind of conversation that you have. If I do assign it a variable, and then I say print conversation history, history. So this is the correct format of showing how it looks like to save on the memory. Okay, so as I mentioned, this is a very simple representation of memory from Langchain. Next, I will go and create a conversation chain using various types of memories here, and then you can basically view how to use different buffer memory or summary memory or different kinds of memory from Langchain. So in order to do that, I will create a new file. I'll call it, making sure that I am in the main directory. So I call it a conversationchain.py. All right, now we're going to build our conversation chain. For this, we need to import the libraries to construct the LLM model that we're using for this chain, and to construct the memory object and build the conversation chain. All right, so let's first import the chains. So from Langchain chains. So we have the conversation chain here. I need to import all the memories. So I import three types of memories from the Langchain memory. So these are dealing with the buffer memory type. So the conversation buffer memory, which we already discussed, the conversation summary buffer memory, which has another capability that I will discuss about that later, and also the conversation buffer window memory, which has another context that you'll learn as you follow this video. Now, there is another type of memory which is called the knowledge graph memory, and it was previously part of the Langchain memory, but now I just recently noticed that Langchain has moved this into its Langchain community. If I go in and do the import the same as I did before, and so this is the conversation KG memory, and let's say if I want to run my conversation chain, I get a warning saying that this is deprecated, this library is deprecated, and then instead of this, better to import it from here. So I just copy and paste it here. And run it and it's gone. So I have the libraries for memory, and then I will import the Langchain prompt library as well. So this is the prompt template. I will be using the OpenAI API, but feel free to use your own LLM. And in order to import the .env components like the APIs and keys, I need to import the .env. So I don't have the .env yet, so I will just install that. Yeah, so that's installed, and the first thing that I need to do is to load and find the .env file. I create the .env file here, and I pass the OpenAI API key. Then I can load that .env file here. And then I instruct my LLM. I'm just using the very simple OpenAI API, just making sure that the temperature is 0. Okay, so it's just getting some storm here, so bear with me a second. And I need to have the prompt template. So first I instantiate the template as such. So this is a statement or a prompt or system prompt that I want to instruct the LLM. The following is a friendly conversation between a human and an AI, and so on and so forth. Then I want to pass the memory content or the conversation history. So I say current conversation. So I have the current conversation, and I pass into a variable called history, and then let's call it a friend, right? A friend. The reason that I'm using a friend, because later on as I am using different namings for the AI and the human, so instead of using AI using human, I'm using the friend, for instance. So here, in order to reflect that, I'm changing this to friends, making sure that I don't have a human anymore. Okay, so now I have a friend, so you can even change it to the name you want, and then I call this the AI assistant, and the response will follow after that. Put that thing in here. So this is my template, and now I want to create my prompt template. So I'm using the prompt template, and then I want to pass the input variables. I will pass the list of variables here, the history and input. So we have history and input, and this is my template. So that's good. And for the memory, as I explained earlier, I have these 4 types of memory. So the first one that I will be using is the conversation buffer memory. I have a prefix for the AI chat and the human. So I'm using the prefix for the user to be as a friend. And then for the AI would be AI assistant. So I have these 4 types of memory here, and then we will see the results for each of these models. So now that I have my LLM, I have my prompt, I have my memory, then I can build the conversation chain. So conversation chain is nothing but passing the LLM, the memory, the prompt. In order to see what it is actually passing through the conversation chain, I would like to put the variables to be true. So the class conversation chain is actually inheriting from the LLM chain. So LLM chain is like the parent library, and it's inheriting all its attributes or properties from here. This is a very simple kind of representation of how you can generate this Python code. You have the memory, as I mentioned, and you also have the prompt here, the input key, the output key. Let's run this to see if everything works for now. So I run this and it got no error, so it should be fine. Here, we're actually using the predict method. So I want to just look under the predict method. So if I command and click on conversation chain, it goes into this class. I'm looking for the predict method. So the predict method is not part of the conversation chain. So I go further into the LLM chain and I search for the predict method, and the predict method is here. So I'm looking at the predict method and it's explaining the arguments and what it returns. Let's pass in another expression. Who will win the Stanley Cup in 2024, Oilers or Panthers? We may want to have this kind of conversation rolling, so I will pass another predict. I want to know how self-attention impacts the performance of transformer models. Once you invoke the prediction of this conversation chain, that will be stored in the memory. I ask another question, one more question, and then at the end, I will ask, for example, a statement, do you know how I started my conversation with you? And so this is sort of a like understanding how the LLM is, having access to the very first conversation or where it just started off. So now let's run it one more time. All right, so you'll get a bunch of back and forth. So if I go and start off from here where I run this, the first thing is the hi there, and then entering another statement. So then it's passing over the memory content. So I have this hi there, and then there's the AI assistant coming again, another. And then I have this question, and then the generated response is coming back. And then I ask another question. The friend, I want to know how self-attention impacts the performance of transformer models. And then the finished chain means that generation was complete. Then I ask the third question, are there any optimization techniques for these models? So I'm actually referring to the transformer models. For the previous question that I asked, are there any optimization techniques for these models? And then let's see how the AI responds. So there are several optimization techniques. So it actually understands that we're talking about a transformer model. So it was able to retrieve from the previous conversation or the previous context what was going on. And then finally, I asked, do you know how I started my conversation with you? And it pretty much understand that it started with hi there, which is the first input statement. So memory is in fact one of those active line of research right now. And I think researchers are really looking into how to make memory, faster so that the LLM get access to the very concise information, providing the content to the user. Now that we know the conversation buffer memory, let's take a look at conversation summary memory. So for conversation summary memory, we're passing an LLM to the class or to the object so that this LLM will be used to summarize the conversation history between the user and the AI. I'm just reducing the number of predicts here, and I want to load actually the memory variables after running this conversation chain. So in the history that I look, it says that the human greets the AI assistant and the AI responds with enthusiasm, asking about the human's well-being. The human asks if the AI remembers how they started their conversation, and the AI apologizes for not being able to remember past conversations. However, the AI expresses its constant willingness to chat with the human. Okay, so now that you can see the way that the conversation summary memory works is it tries to summarize what has been as a conversation in the previous dialogues. The next thing that we're going to look at is the conversation buffer window memory. So this is another example of the conversation buffer memory, but in this case, we're just looking at the last 4 messages or chat history of the conversation between the AI and the human. Okay, so if I run this one more time, I get this error. It says that the prompt expects history and input, but got chat history as input from memory. So if you recall here, I have the history here, but here in the memory key, I changed it to chat history. Now, if I go to the conversation summary, the name for this memory key by default is called history. So I need to fix this error. Okay, so now after changing the history variable within a template and a prompt template, then everything works now. Okay, this is a little bit long, so what I can do is so I assigned the conversation history from the memory, so I load conversations into this variable, and then I'll call it on this key. Run it one more time. So it starts with, I want to know how self-attention impacts the performance of transformer models. And if I look here, in the third question, I'm actually seeing that statement. So it means that the first 2 questions and the corresponding responses are gone. So what happens is the memory is actually sliding down to kind of store only the past 4 conversations. So lastly, we're going to talk about conversation knowledge graph memory. So Langchain introduces conversation knowledge graph memory, which harnesses the power of knowledge graphs to store and recall information. By doing so, it aids the model in comprehending the relationships between different entities, enhancing its ability to respond based on the intricate web of connections and historical context. So let's take a look at example here. So I instantiated this conversation knowledge memory, and I'm passing an LLM to this one. And I ask a couple of questions, and then I get the triples from this knowledge graph. So now this has been done, and so I ask the question, do you know how I started my conversation with you? And it's actually not responding with the exact statement that was passed through, but it knows that it started with a hello or something similar to that. So knowledge graph is providing, this is the closest context to what has been passed. And if we look at, the triples here, so we have, some of these statements that was helpful in order for the LLM to generate the response. So we discussed about different types of memory, and in particular, we worked with the ConversationBufferMemory, ConversationSummaryMemory, and the ConversationBufferWindowMemory. We also look into an example of the conversation knowledge graph memory from Langchain. I hope that this video was helpful for you, and if so, please give it a thumbs up, and I'm looking forward to see you in my next video. Until then.